DAX. DAX stands for Data Analysis Expressions. DAX stands for Data Analysis Expressions. DAX is the formula language of the Power BI. So Power BI is same like the mathematics case. In mathematics, how we are going to solve the problems? In mathematics, we're going to solve the problems by writing the formulas. Same like that in Power BI also, every day we're going to do a lot of analysis. Every analysis we do in Power BI is having some logic behind that. So how we are going to write those logics is using DAX. So in Power BI also, we are going to do the step-by-step derivations by writing those formulas, right? So in Power BI, as we're going to write the formulas using the DAX, what are the different types of formulas we're going to write? In DAX, mainly we're going to create three types of formulas. The three types of formulas are number one, calculated columns. We're going to create the calculated columns. Number two, measures. We're going to create the measures. And number three, we're going to create the tables. Using DAX, mainly we are going to create three types of formulas. Using DAX, mainly we are going to write three types of formulas. The three types of formulas are number one, calculated columns, number two, measures, and number three, tables. So what is the difference between each type? Let's understand. So how we are going to write the formulas? So DAX formula syntax is quite simple. DAX formula syntax is just simply name equals to formula. The formula syntax is name equals to the formula. In the LHS side, we have to give some name. In the RHS side, just we need to take the formula. This is syntax of the DAX. So where are we going to create these formulas? In Power BI, once we complete your data modeling, we'll go to the, after completion of the data model, go to the data window. Here we got the data window. In the data window, as you could see here, in the data window, here once you click on this data tab, in the data window, we're going to see here options of writing new column. So we're going to create a new column. We're going to create a new measure, and also we're going to create a new table. So we are going to create a new column. We are going to create a new measure, and also we're going to create a new table. So we are going to write altogether three types of formulas. Altogether, we're going to write the three types of formulas. Okay, as we're going to write here three types of formulas, let's explore how to create a column, how to create a measure, and how to create a table. To start with column. So to create a column, we need to just click on here new column. Once you click on new column, what column gonna do is it will add a new column to your table, guys. Whatever the table you are having, to your table, it will add a new column. So calculated columns will add a new column to the existing table. As it is adding the new column to the existing table, so calculated columns are computing instantly. As the column is getting created instantly, so the logic is executing at the back end instantly. So for example, here I'm adding a column to find out, let's say, the length of the email address. So here I'm giving some name, email length. To get that length, I'm using here one function. In the right hand side, I'm writing the formula. Formula contains functions, guys. Here I'm using one function called as len. Len is used to get the length of the string. I'm taking here length of the email address. So I'm just copying it. It is going to give me the email ID length. So now here we got the length of the email ID, as you could see here. So as the first type of formulas we can write are the calculated columns. So calculated columns, what the calculated column is doing is it is adding a new column to the existing table. It is adding a new column to the existing table. As it is going to add a new column, it will compute instantly. It will compute instantly. The moment we write the logic, instantly it will compute that logic. And it will compute that logic on each row. It will compute instantly on each row. So on each row, whatever the logic we are writing, it will execute. So we are computing here the length of the email address here. So the in every row I got the email address, on every row it is computing the length, and the length we got here. And the length we got here. So this is the length of the email address here we are having, right? Perfect. Next. And whatever the calculated columns we are having, as they're computing instantly on each row, so the calculated columns are having the row context. It is called as row context. So this calculated columns are having the row context. Row context means computing on each and every row. Row context means computing on each and every row, or executing on each and every row is called as the row context. And the calculated columns will recompute every time. Calculated columns will recompute every time whenever we click on the refresh. So whatever the calculated columns here we're having, the calculated columns, they'll compute every time whenever we click on refresh, right? So so the calculated columns here, what are the columns we're adding? These columns will compute every time whenever we click on refresh. So whenever we right click on the table and we click on here refresh data, whenever we click on the table, and whenever we click on refresh data, what this calculated columns will do is this calculated columns will recompute every time, guys. So the calculated columns will recompute every time whenever we do a refresh or whenever we close and reopens the Power BI. Whenever we close and reopens the Power BI, it will recompute every time. And this calculated columns, as it is adding a new column to the table, it consumes the memory. It consumes your memory. And also calculated columns, it needs calculated column, it needs the processing power to execute that logic every time. So whatever the logic we are writing to execute that logic every time, it needs the processing capacity, it needs the processing power. So calculated columns are not recommended every time. Calculated columns are not recommended every time. If you want to create a column, instead of creating column at the DAX level, what we can do is we can create a column at the Power Query level. So if you have the choice between the Power Query and the DAX means, so create that column at the Power Query level. Don't create columns at the DAX level, because most of the calculated columns, they contains static values. Most of the calculated columns contain static values, means the values won't change. On the static values, we keep on recomputing every time, means even though the values won't change, but every time if it is recomputing means it's just going to consume your memory. Just going to when I say memory, the primary memory. Calculated columns will make use of your RAM. It will consume your RAM. If it is consuming your RAM means that it will make your system to get slowed down, right? So this is all about the calculated columns. So repeat again, what are calculated columns? What calculated columns are doing? Calculated columns, it is adding a new column to the existing table. As it is adding a new column to the existing table, so it will consume your memory. Not only consuming your memory, every time it will recompute whenever we click on close and opens. Whenever we click on close and open, just going to recompute every time this. As a result, it needs some processing capacity as well. And most of the calculated columns contains the static values. If you're recomputing every time means the value won't change. And also these calculated columns are having row context. Row context means what? Row context means it will execute the logic on each and every row. It will compute the logic on each and every row, right? It's all about the calculated columns. The second type of formulas which we are going to create in the DAX are measures. So what the measures going to do? What the measures going to do? Measures, it won't add any new column to the existing table, guys. It won't add any new column to the existing table. This is one advantage. If you go to any interview, it is a common interview question, guys. If you go to any interview, it is one common interview question difference between the columns and measures. So measures, it won't add any new column to the existing table. For example, here I'm having this table. On the table, I'm adding a new measure. What this measures need is measures need some aggregation. Measure needs some aggregation. We need to add some aggregation like min, average, max, like that. So here I'm adding a measure. I would like to take average annual income. So here I got a measure. I'm naming this as average annual income. I'm just taking here average of annual income. So here I created a measure, the name average annual income. So the average annual income column is not getting added to this table. You could see here that average annual income column is not getting added to this table because measures, it won't add any new column to the table. So it means measures, it won't consume any memory. It won't consume memory. And also it won't recompute every time. It won't recompute every time. And it won't execute on each row, unlike the column. Then where the measures going to execute? Measures are having filter context. Measures are having the filter context. Filter context means measures will execute at the visualization level, guys. Measures will execute at the visualization level. So we're going to create visualizations at the report level. Let's go to the report tab. In the report tab, I'm just going to the customer table. In the customer table, I'm just taking here average annual income, and I'm taking here, let's say, when I take your average annual income, it is showing here the average annual income as 57,000, right? I'm taking this average annual income. I'm taking here average annual income along with the a dimension. I'm taking here, let's say homeowner. So I'm taking here average annual income for the homeowner. So the people having home, Y means they are the homeowners. Their average annual income is 58,000. The N means no home. People who are not owning any house, their average annual income is 55,000, right? So when I take here a dimension, the average annual income got filtered here. Along with the homeowner, or I'm removing homeowner, I'm just taking here educational level. When I take an education level for each and every education for the graduate degree, bachelor's, it is showing up the average annual income. Now the average annual income is showing up here for every education level. For every education type, it is showing us the average annual income. So what is happening here? Whatever the average annual income we are having, that is filtered down based on the dimension we are having in the visualization or not. So based on the dimension we're having in the visualization, for example, I'm taking here occupation. Now again, the annual income got segregated based on the occupation and the education level. So this is called as filter context. Measures are having filter context. Filter context means the measure values are filtered down. Measure values are filtered down based on the dimensions we are having in the visual. So filter context we are having at the visual level. So based on the dimension we are taking into the visual, okay, the measure value going to change. So one measure produces different results based on the dimension we are having in the visual case. One measure, the measure we have is average annual income. This is giving us different results. The measure is giving us the different results. So how the measure is giving us the different results? Measure is giving us the different results based on the dimension we are having in the visual. So a measure produces different results based on the dimension we are having in the visual. This is called as filter context. This is called as the filter context. Okay, right. Next, whatever the measures we're having, these measures, as they are not consuming any memory and as they're not computing every time, so measures gives good performance. Measures gives the good performance, and measures are always recommended. Measures are always recommended. At the DAX level, we mainly create the measures case. At the DAX level, we mainly create the measures. So whenever you are creating any measure, always you have to keep one thing in mind. Measures are having filter context. It is also one of the important interview question. What is filter context? How it is different from the row context? So what is filter context? Filter context means what? A measure produces different results based on the dimensions we are having in the visual. That is called as filter context. Filter context means the measure values are getting filtered. Measure values are getting filtered based on the dimensions we are having in the visual. That is called as the filter context. And what is row context? Row context means computing the values on each and every row is called as the row context. A row means it will compute values on each and every row. So which are recommended? Are columns recommended or the measures recommended? Always measures are recommended. And the third type of formulas we can create using the DAX are calculated tables. Calculated tables also consumes the memory. Calculated tables also consumes the memory because a table going to have what multiple columns. Column needs what storage, so it consumes your memory. So calculated table, what it will do is it will add a new table to the, it will add a new table or it creates a new table. It creates a new table. As the table create a new table, so table going to have a lot of columns. Column needs storage, so it consumes your memory. So again, important point is it is not recommended to create tables at DAX level. To create tables at the DAX level, Always it is recommended to create a tables at again Power Query level. At Power Query level, we have an option of creating the tables as well, right? So once let me go back to the Power BI and Power BI. Once you go to the data window, in the data window, once you click on tables, in table tools, you could see here an option of adding a new table. So once I click on here new table, this option will automatically create what? This option will automatically create a new table, and we have to give here some logic to create a table, right? But again, table creations are not recommended at the DAX level because again, they'll consume the memory, it will degrade your performance. So I'm creating one table using one function called as calendar. Calendar will create a list of dates. So I'm taking here my starting date as 1st May 2023. I need to take starting date and I need to take ending date as 4th May 2023. So just I'm creating a table with 4 date values. It is going to give us the calendar now. So now you could see here the date. So here we got 1st May, 2nd May, 3rd May, and 4th May. Perfect. All right, so I'm changing here I'm just on the date column. I'm changing the data type of this to just a date. So now here we got the date column. All right. So again, tables is not recommended. So it just going to degrade your performance. Just going to degrade your performance. So always the point is, whenever you are creating any DAX formulas, always in real time, we mostly create the measures. Columns and tables we can create at the Power Query level. Now, if you are creating a column or if you're creating a measure or if you're creating a table, what is the syntax we're following? We're just following your name equals to formula, right? The same syntax we're following. Now, what this formula contains, for example, if you see this example, what our formula contains? Your formula contains, for example, if you see here, number one, function. Here, alien is the function. Here, alien is the function. And your formula contains table name. Here, AW customers is the table name. Formula contains function, it contains table name, and also formula contains the email address. Email address is the column name. So it contains the function, it contains the table name, and also it contains the column name, right? And also it contains operators. And here it contains FQN. FQN stands for fully qualified name. Here, the combination of this table name plus column name, the combination of this table name plus column name is called as the fully qualified name. So your DAX formula contains is 5 things. Your DAX formula contains number one, function. What is a function? What is a function? So function, it takes some input. The definition of function is simple. The definition of function is f of x equals to y. The definition of function is f of x equals to y. What is f of x equals to y? Here f is a function taking some input called as x and giving us some output called as y. So function takes some input. Function takes some input and gives us some output, guys. So the major part in the DAX logics is knowing the functions. So always functions, we are going to use some input and functions going to give us some output, guys. So how many functions we're having in the DAX? DAX is having more than 200 functions. Okay, DAX is having more than 200 functions. You have to remember all those functions. Those functions have been classified into different types. Whatever the DAX functions we're having, those functions have been classified into different types. So what are the different types of functions we're having in the DAX? Let's first understand different DAX function categories. DAX are mainly classified into, DAX functions are mainly classified into 12 types, guys. I have classified them into 12 types for easy understanding and for easy remembrance. So I categorize with the DAX functions into 12 categories. I have categorized the DAX functions into 12 categories. Those 12 categories are, number one, the first type of functions are number functions. The first type of functions are number functions. The second type of functions are text functions. The second type of functions are text functions. The third type of functions are date functions. The fourth type of functions are logical functions. The fifth type of functions are information functions. The sixth type of functions are filter functions, the most powerful functions. The seventh type of functions are aggregate functions. The eighth type of functions are iterator functions. The ninth type of functions are very important time intelligent functions. Time intelligent functions, right? And the 10th type are table manipulation functions. table manipulation functions. All right. So we have two more types. The next type is parent-child functions and other functions. I'll just write it here. The 11th type is parent-child functions, and the 12th type is other functions. Right? These are the 12 function categories we are having in the DAX. So in order to get perfection in the Power BI, the most important thing what you need to practice is DAX. So you need to understand the function type and the use case in the real time, right? And also how to solve the problem. So I'll discuss each and every function type in detail. So if you're good with these functions, then you're done with Power BI. So all the remaining things are very easy. The most important thing in the entire course is this DAX. In the DAX, again, the most important thing is the function categories. So these function categories are very, very important. So these are the 12 different function categories you are having. So the first thing in the DAX is the function. So you need to identify the function and you have to write the logic. So in the DAX, what is the first one is the function. So just now I discussed it. We got 12 different types of functions. I'll discuss each and every type in detail. Right. The next thing is the table name. The table name directly you are going to get from our data model. From our data model, you are going to get the table name. And every table contains what columns, right? So table name and column name are available. We don't need to do anything. And the combination of the table name plus column name, for example, the combination of this table name plus column name is called as fully qualified name. This is one of the important certification question in Power BI. What is FQN in Power BI? So FQN is the fully qualified name. Fully qualified name is the combination of the table name and column name. How they will give this in the certification exam is they'll provide you a question stating that identify or select an option which is acting as a fully qualified name. They'll give you the options like this. First option is like this. Option 1. Option 2 is like this. Okay. Option 3 is like this. Option 3 is like this. And option 4 is none. So what is the fully qualified name here? Which is having the fully qualified name? So in the certification exam, they'll give you the options like this. So which is having the fully qualified name. So option 1 is having the fully qualified name, the combination of the table name plus column name, right? And the next important thing in the DAX formula is the operators. This is the next important thing. The next important thing in the DAX is the operators. So in the DAX formulas, we are going to take the operators piece. Now let's talk about the DAX operators. Now let's talk about the DAX operators. So DAX is having different types of operators, like it is having the arithmetic operator. We got different arithmetic operators like addition, subtraction, addition, division, subtraction, right? We got so many arithmetic operators. So whenever you are writing any DAX logics, we can use these arithmetic operators, and we can use the relational operators as well. Relational operators as well. So the relational operators means we can use greater than, less than, right? We can take less than or equal to, greater than or equal to, like this. We can use the relational operators as well. These are quite simple. Arithmetic and relational operators are quite simple. And the next one is we can use the logical operators as well. inside the DAX, we're going to use the logical operators as well. So in the logical operators, mainly we are having four operators. The four operators are number one, logical and it will just perform the AND operation. To perform the logical AND, the operators we need to take is double ampersand. In the DAX, to perform the AND operation, we need to take double ampersand. So let's understand this logical AND. Just going back to the Power BI, and here I'm going back to one of the tables here I'm having. So what I'm doing is here I'm adding a new column. How to add a new column? In the top, click on Table Tools, click on New Column. This is one way of adding a new column. We can add column in the another way as well. The second way of adding the column is simply right click on your table. The table I'm having is the AW calendar. I'm right clicking on the table. And when you right click on the table, here also we have a new column. If you have multiple tables here, like this, then the best way to add a column in a specific table or add a measure in a specific table is simply right click on the table and here choose an option to add a new column or measure. What this option going to do is this option will straight away add the column or measure in that table directly. I'm adding a new column here. The new column we are having is so here I'm adding a new column. In the new column here, I'm just giving I'm just doing here AND operation. I'm taking here. So 1 is greater than 2, double ampersand. 2 is less than 3. What is the output of this? Here I have taken AND operator. What AND operator needs? If both the conditions are true, then the final result is true. So 1 is greater than 2. Is 1 greater than 2? No, this is false. This is false. Next, 2 less than 3. Is 2 less than 3? Yes, this is true. So here we got AND operator. So AND operator needs what? Both the conditions to be true. If both the conditions are true, then AND will give us what? The result as true. But if only one condition is true, another condition is false, so the final result is what here? False. So the final result here is false. Just going to give us false in every row. Just going to give us a false in every row here. See here we got false in every row like this. And here I'm adding here OR operator as well. I'm adding here a new measure again. Sorry, new column again, not measure. So how to perform the OR operation in the DAX is to perform the OR operation, we are going to use the logical OR operator. So the logical OR operator we have is simply double pipe. We have to use the double pipe symbol. Using double pipe, we can perform the logical OR. Taking here OR operator. So I'm taking here 1 is greater than 2, double pipe. 2 is less than 3. So is 1 greater than 2 true or false? 1 greater than 2 is false, but 2 less than 3 is true. So OR needs what? If any one of the condition is true, just going to give us the end result as true like this. So as you can see, for both logics here, I created columns. Columns are computing on every row. See here, columns are computing, it is stamping the true or false values on every row because columns are having the row context, right? And next thing is the next we have is ampersand. We can here use one more operator called as, this is not a logical operator, this is a different operator. We're going to use ampersand. Ampersand, it performs string concatenation. ampersand, it performs string concatenation. We would like to concatenate two strings. We would like to concatenate two text values, then we are going to use this ampersand. So I'm just going back here to the Power BI. In the Power BI, here I'm adding a new column again. So I'm just taking here string concat. So I'm just taking here Power BI is one string. Always remember one thing. Inside the DAX, if you're writing any formulas, the text values, Power BI is one text value, right? The text values, we need to take it in the double quotes. Always the text values, we have to take it in the double quotes like this. So Power BI, I'm concatenating using ampersand. So Power BI, I'm concatenating with space. Space is also a text value. So space also I'm taking in the two quotes. Again the space I'm concatenating with Microsoft. So Power BI, I'm concatenating with space. Again space, I'm concatenating with Microsoft. So we're concatenating here three characters. We're concatenating here three text values. So Power BI is one text value. So here space is the second text value, Microsoft is the third text value. I'm just hitting enter. Now it is giving us, you could see here the Power BI Microsoft is concatenated into one single column. We could see that value here like this, right? Okay. And also what we could do is we could able to use here the in operator. The next operator which we are going to use in the DAX is the in operator. This in operator is a kind of multiple OR operator. Multiple OR condition operator. If you would like to pass multiple OR conditions, we can here use this in operator. So how to pass this in operator is we need to take here some column name. We need to take here some column name in of. We need to take here curly brackets. We need to take your values like V1, V2, V3, and so on like this. So what the in operator gonna do is in operator is a multiple OR operator. So in operator will look for any one of the values in the column. So it is something like column name equals to V1 or column name equals to V2 or column name equals to V3 or and so on like this. So it is something like this. So whatever instead of writing a lengthy formula like this, inside here the DAX, we can take our list of values in the curly brackets. It will just look for all this and it will just look for every value in the column name. If any one of the values existing, what R needs just one condition to be true, right? If any one of the value is existing there, it's just going to return the output as true, else it returns the output as false. Okay. So now let's write that. Let's go back here to the Power BI. So here I'm having subcategory name. In the subcategory name, I would like to see whether my subcategory is having caps. Okay, gloves. So I would like to know whether my subcategory is having caps and gloves or not. So here I'm adding a new column again. So in operator, just taking here my product subcategory in of. in of, where to take here curly brackets. And whenever you're writing in a DAX formula, it is indicating here with this number one. What this one indicates is currently we are in the first row. If you want to go to the second row, you need to press Alt Enter. Currently, we are in the first row of the logic, right? If you want to write this, if you want to go to the second row, press Alt and Enter button in your keyboard. Once you press Alt Enter, it will take you to the second row like this. It will take you to the second row like this, like this. So subcategory in of, so the text values here I'm having, so I'm just taking here my text values. So one is the wheels and other one is the, let's say, jersey. And yeah, jerseys and caps. Just hitting enter. So now it is giving us a false because what it is doing is it is executing on every row. Its subcategory name is mountain bikes. Is mountain bikes matching with wheels? No. Is mountain bikes matching with jersey? No. Is mountain bikes matching with caps? No. Okay, so all this is false. If we come down, here wheels is there. Is wheels matching with wheels? Yes, it is true. Is wheels matching with jersey? No, it is false. Is wheels matching with caps? No, it is false. So at least one condition is true. It will give us end result as true here like this. It is giving us the end result as true. So like this, we can here use the in operator guys. These operators we mainly use in the DAX. These operators we mainly use in the DAX. So all these are the DAX basics you need to know before writing the DAX formulas. So I'll repeat again, what is DAX? DAX stands for Data Analysis Expressions. DAX is the formula language of the Power BI. In DAX, every day we are going to write the formulas. So mainly we are going to create three types of formulas. The three types of formulas we are going to create in the DAXer. We are going to create calculated columns, we are going to create measures, and we are going to create the tables. So what is a calculated column? Calculated column will add a new column to the existing table. So calculated column will recompute every time whenever we add a new column. Calculated columns will be as they're computing every time. How they're computing every time is they're executing on each and every row. So they're having row context. Calculated columns are having row context. As they're having row context and they're adding a column, it needs some storage to store them. So it consumes your memory, and also it needs more processing capacity to execute that logic on each and every row. So calculated columns always going to impact your performance. So it's not recommended to create the calculated columns, as most of the times they contain static values. So calculated columns are recommended to create at the Power Query level. What about measures? Are measures adding a new column? No. Measures are not adding a new column to the table. So measures doesn't need require the storage. It is not computing every time. It is not executing instantly. Measures are having what? Filter context. Filter context means single measure value can produces different results based on the dimension we're having in the visual. That is called as the row. That is called as the filter context. Always measure gives the good performance, so always the measures are recommended. And again, in the DAX, we're going to create the tables as well. So what tables going to do is it'll add a new table to the existing list of tables. So it needs some storage, it needs some processing capacity, it's going to consume more memory, so it's not recommended as it is going to impact the performance. So these three types of formulas we're going to create at the Power BI. So to create a table, we need to go to the data window in the table tools. We can add here a new measure, we can add here a new column, and we can add here a new table. We can create the three here like this, or the other option is we can just right click on any table. Once I right click on any table, here also we have the options of creating a new column or creating a new measure. right? And how to write the DAX formula? The syntax to write the DAX formula is name equals to formula. Name equals to formula. What the DAX formula contains? DAX formula contains function, table name, column name, operators, and also fully qualified name, name, right? So as we got all these things in the DAX formula, the most important things are functions and the operators. We got different types of DAX functions. DAX functions are mainly categorized into 12 types. These are the 12 different types of DAX functions. And also we have got the operators. In the DAX, we got mainly arithmetic operators, relational operators, logical operators, how to perform logical and using double ampersand, how to perform OR using double pipe, how to use an operator using the curly brackets. And we can do here string concatenation using the ampersand as well, right? So as we discussed the list of functions, so I'm going to start the number functions from the tomorrow session. From tomorrow session, I'm going to start the number functions. In the today's session, I just discussed about the DAX introduction. It's all about the DAX basics. We'll start number functions from the tomorrow session.